Welcome to this course. My name is Fortunato Bentolila. I am a physicist and I will do a more appropriate introduction face to face. And today I want to discuss one problem and I would like that you come prepared for the class, and it's the tangent line problem. During the course, you will have all my PDF to study carefully. I will give you to do many problems with business applications from your textbooks. The textbook is Hoffman. And let's go to start by defining what is the tangent line problem. So imagine you have 2 points. What is the slope of 2 points? So you have a coordinate. Let's say the x and the y. And suppose you have 2 points. Point P have a coordinate, the x1, and the height is y1. And point Q has a coordinate x2 and y2 height. So what is the slope? What is defining the slope? The slope is the rise divided by the run. The slope is rise divided by run. Slope equal rise divided by run. What is the rise? The rise is this rise, and this rise is y2 minus y1. What is the run? The run is this amount from here to here, and this is x2, that is everything, minus x1. So the run is x2 minus x1. So we have defined the slope that exists between 2 points that are connected by a rectilinear line. So this is the rectilinear line. The rectilinear line that connects the 2 points PQ. And this is the slope. Now the question is, what will be the slope for an arbitrary curve? And this is the tangent line problem. The tangent line problems means how to find the slope at the instantaneous slope at one point P of the curve. So let's go to do one example to find the instantaneous. And this is calculus. Calculus is based to find the instantaneous change, the instantaneous slope of the curve. Sometimes this equation of the slope is written like this. Slope equal delta y divided by delta x. And what is delta y? Delta y is y2 minus y1. And what is delta x? Delta x is x2 minus x1. So let's go to do problems for this section. You read the PDF, the complete PDF, and I will do the problems for you so you can get a better idea how to do the problems. Well, this is the PDF. Here we define the slope. Here the point slope equation, the equation of the rectilinear line that pass through the point x1, y1 with the slope m is the equation y minus y1 equal m multiplied by x minus x1. We will use this equation and I will deduce in class this equation. You can read the summary and you can read this problem, and let's go directly to do the problems that are proposed here. The first problem say find the equation of the tangent line to the parabola y equal x squared at the point 3.9. So let's go to find the equation of the tangent line to this function, that is y equal x squared. So when x equal 1, the y equal 1 squared. So when x equal 1, the y is 1 squared. When x equal 2, the y is 2 squared. When x equal 2, the y is 2 squared. When x equal 3, the y is 3 squared. 3 squared is 9, so the y is 9. And the problem is asking, what is the equation of the tangent line, this line? What is the equation of this line? So the P is here. The P is at the point 3, 9. The P is 3, 9. And the Q is a point that is coming to approach P as much as they can, but is never P. Is the components is x, comma, x squared. This will be x squared. So the Q is approaching. So when the x is approaching to 3, what will be the slope? So you can see in the image that when Q is approaching to P, the slope is changing. So the question is, when Q is here, the slope is like this. Oh, let's go to do it more easy to see. When Q is here and P is fixed, the slope is like this. But when Q is here and P stay fixed, the slope is changing. So the question is, what is the slope when the Q is here, when the Q is approaching P? When the x is approaching to the point x equal 3, what is the slope? So let's go to calculate. The slope m is the rise divided by the run. The rise is y2 minus 1. The run is x2 minus x1. So this y2 corresponds to the point Q. This x2 corresponds to the point Q. So the slope will be delta y. Delta y will be x squared minus 9. X squared minus 9. This is delta y divided by delta x. Delta x will be x2 minus x1, or x minus 3. And what we want to figure out is what is the limit when x tends to 3 of x squared minus 9 divided by x minus 3. To make this limit that we will do formally in the following classes, we remember that always x is a squared minus b squared is a minus b multiplied by a plus b. So using, you can check this equation, a by a squared, a by b, a multiplied by b, minus b by a, it cancels with the a by b, minus b squared. Minus b squared, this will be a squared minus b squared. Perfect. So what is the limit when x approach to 3, when the point Q is approaching to the point P of this x squared minus 9 divided by x minus 3? So I will write x squared minus 9 like x minus 3 divided by x plus 3, multiplied by x plus 3 and divided by x minus 3. This x minus 3 will cancel, And now it will state the limit when x goes to 3 of x plus 3. And when x goes to 3, the value of the x is 3, so the slope, the m, will be 6. So what is the equation of a rectilinear line? The equation of a rectilinear line is y equal y1 plus m multiplied by x minus x1. What is y1? Y1 is the point P that is 3, 9. Who is y1 is 9 plus m, who is multiplied by x minus x1. x1 is 3. So if we solve a little bit, it would be 9 plus 6x minus 18, or y equals 6x minus 9. So this is the equation of the rectilinear line that passes through the point P and is tangent to the curve y equals x squared. It touched the point only once. The point P is the point 3, 9. Okay, let's go to do another problem. Now, this problem is almost the same one. We have the same function. Now, the point P has changed. Now, the function is y equals x squared. And what we want to find is at the point 0, 0, on here, at the point 0, 0, what is the equation of the slope? It's clear that the slope will do like this, will touch horizontally, so the slope have to be 0. There is no slope. So let's go to find the slope will be that m, so we are imagining a point Q. The point Q is moving through to the point P. This is the point P, the 0, 0. As he's moving, the slope is changing. And the question is, what is the slope when the point Q is so near as the point P? When the point Q is so next to the point P, what is the slope? We know that the slope is 0, but let's go to calculate. So m is delta y divided by delta x. What is the point P? The point P is the point 0, 0. What is the point Q? The point Q have the coordinate x squared. So the point Q is the point x comma x squared. When the Q is here at the x, the height is x squared. When the Q is here at the x, the height is x squared. So the point Q is x comma x squared when he's moving through this particular function y equals x squared. So delta y is y2 minus y1. What is y2? Y2 is the x. Y2, is the x squared. Y2 minus y1, so it will be x squared minus 0, divided by x2 minus x1. x2 is the x minus x, x2 minus x1 is the 0, so it will be x minus 0. And what will be the limit when x approach to 0 of x squared divided by x? Or what will be the limit when x approach to 0 of x squared divided by x is x. When x approach to 0, what value will take the x? Will take the value 0. So we have discovered that the m is 0. And what will be the equation of the rectilinear line? The equation will be y equal y1 plus m multiplied by x minus x1. Y equal y1. Y1 is the point P, is 0. M is 0. By x the multiply minus x1, x1 is 0. 0 by x is 0, so y equals 0 is the equation of the line that is tangent to the curve up to the parabola at the point 0, 0. And y equals 0 is the x-axis. Y equals 0 is the x-axis. So this is the equation. So this problem we will do during time class. Please try to do it. We will discover exactly how to do it correctly. I'll see you soon. Now to do this problem, you do exactly what we have done, only that you need to remember that x cubed plus 1 can be factored into x plus 1 multiplied by x squared minus x plus 1. If you multiply this expression, these two factors, you will obtain this one. So using this idea, you can find the slope of the tangent line through the curve y equals x cubed at the point minus 1, minus 1.